are one of the most commonly used areas, but they're also one of the easiest places to spread germs and bacteria. So our goal is simple: to create a smart, hygienic, and hands-free bathroom system that automatically opens the door and flushes the toilet using Arduino technology. This project doesn't just aim to be convenient, it aims to promote cleanliness, accessibility, and innovation. Our project was made to make daily bathroom use more hygienic, more convenient, and definitely more intelligent. By combining automation and innovation, we're turning ordinary bathrooms into smart, touch-free environments. Before building the real thing, we designed and tested everything through virtual prototyping. We used Tinkercad, a powerful online simulator that lets us create circuits, upload Arduino code, and see how each component behaves in real time. Through virtual prototyping, we could easily fix wiring mistakes, test sensor responses, and fine-tune the servo motors, all without using a single physical component yet. It's like building the project inside the computer first, saving us both time and resources. This method gave us confidence that our design will work perfectly once we build it in real life. In Tinkercad, the PIR motion sensor, which detects movement through infrared signals, does not exist or isn't available in the component library. Because of that, we needed a substitute, something that could still send a signal to the Arduino to represent motion detected. So we used a push button as a manual trigger. Let me explain how we connected everything, step by step. First, we connected the push button to the Arduino's digital pin D2. This button serves as a substitute for the PIR motion sensor. When pressed, it sends a high signal to the Arduino, simulating that someone has entered the bathroom. We also added a 10K ohm resistor connected to ground. This acts as a pull-down resistor, keeping the signal stable and preventing false triggers. Second, we connected the ultrasonic sensor to detect the user's hand above the toilet flush. Its TRAD pin is connected to D3, and its echo pin is connected to D4. The VCC and GND pins go to the 5V and GND rails of the breadboard. This sensor measures distance by sending and receiving ultrasonic waves. If it detects an object within 10 centimeters, it triggers the flush servo. Third, we have the door servo motor, connected to pin D5. This servo opens and closes the door automatically. It receives its power from the 5V and GND rails, and its signal from D5. Fourth, the flush servo motor is connected to pin D6. When the ultrasonic sensor detects a hand, this servo pulls the flush lever and then returns to its starting position. Handle flush. This function manages the ultrasonic sensor. It sends sound waves and measures how long it takes to bounce back. If it detects a hand within 10 centimeters, it activates the flush servo motor. The servo moves to pull the flush lever, waits for 1 second, and then returns to its original position. This creates a smooth, touchless flush. No physical contact needed. Lastly, we powered the entire circuit using the Arduino's 5V output and GND, which we connected to the breadboard's red and blue rails. This allows all components, sensors, buttons, and servos to share a common power source. Here's our complete circuit diagram, created in Tinkercad. At the center, we have the Arduino Uno, which acts as the brain of our project. We connected several components to it. A push button, which replaces the PIR motion sensor. When pressed, it simulates a person entering the bathroom. An ultrasonic sensor, which detects a hand near the flush handle. This allows the system to flush automatically. 2 servo motors. One controls the door and the other activates the flush lever. A 10K ohm resistor, connected to the push button as a pull-down resistor, ensures that the signal is always stable and accurate. All parts are powered through the Arduino's 5V and GND pins, connected neatly on the breadboard. The moment I click Start Simulation, everything comes to life, just like a real automated bathroom. And now the heart of our project, the Arduino code. This code gives life to our circuit and controls every action in the system. It starts with including the servo library, which allows us to move the servo motors smoothly. In the setup section, all components are initialized. The button, ultrasonic sensor, and both servos are set to their default positions. Let's break it down step by step. First, we included the servo library. This library is very important because it allows us to control the servo motors precisely. Without this library, we wouldn't be able to make the door or the flush move smoothly. Second, we declared all the pins that are connected to the components. For example, the button is connected to D2, the ultrasonic sensor uses D3 and D4, and the 2 servos are connected to D5 and D6. This step helps the Arduino know exactly where each part is wired in the circuit. Third, we use the setup function. This is where everything begins. Here we set up all our inputs and outputs and attach the servo motors to their correct pins. We also make sure both servos start at their initial positions. the door closed and the flush idle. This makes sure our system starts safely every time we run the code. Fourth, inside the loop function, the Arduino continuously runs two main processes. Handle door button. This function reads the push button input. When the button is pressed, it sends a signal to open the door. The door remains open for 5 seconds, and then the servo automatically moves back to close it. This is the same behavior a PIR sensor would have in the real setup, so the code simulates motion detection perfectly using the button. Finally, all these actions are placed inside an infinite loop, meaning the Arduino continuously checks for inputs and responds instantly. So now when we click Start Simulation, pressing the button simulates motion, opening the door servo automatically. After a few seconds, the door gently closes again. When a hand is placed near the ultrasonic sensor, the flush servo activates and performs a touchless flush. Everything works together, the sensors, servos and button, thanks to this simple but powerful code. That's the beauty of Arduino. A few lines of code can make something ordinary, truly smart. To sum it all up, our smart bathroom automation system shows how technology can make everyday environments smarter, safer, and more hygienic by using simple components like sensors, buttons, and servos, and combining them with Arduino. We created a system that not only improves hygiene but also makes bathrooms more accessible for everyone. Thank you for listening, and we hope our project inspires others to create innovations that make the world a little cleaner, smarter, and better.